professor of computer science and electrical and computer engineering at Carnegie Mellon University, and the co-founder and chief technology officer of Panasas, the long thing. Panasas comes from my CMU research, and my CMU research comes from my investment in large-scale storage and high-performance storage over the last, I don't want to say. My roots, and what most people actually have heard of, is RAID. So RAID was my PhD research. It set out, when I set out to do RAID, it was about parallelism and being able to get higher bandwidths and higher performance out of storage. But it became about reliability. And the RAID, as we all know it, has been about protection against failure of disks. And I have actually been doing RAID-like things and RAID innovations continuously since that first paper. Some of them have taken a lot longer to have an impact. For example, in the early 90s, we did declustering. This was spreading out a RAID group over more disks than required in order that the reconstructions could be faster, parallel reconstruction, and less impactful of the user workload. That we did again at Panasas in 2000, and it's now showing up. Other groups are beginning to do the same parallel reconstruction, scaling of reconstruction work in things like key value stores in RAM cloud. So I think you'll see more and more about making recovery and reconstruction algorithms more effective, more parallel, and less in the way. Another thing that we did at CMU in the early 90s was to recognize storage could become on the network as a first-class citizen. This is a fiber channel made me think, this isn't any different than Ethernet. It was, but not that different. So we developed a architecture for storage as a first-class citizen, and this architecture was called at the time Network Attached Secure Disks, or NASD. And then it became the T10 SCSI standard OSD, object storage devices. And that was standardized first version 1 in 2004, version 2 in 2009. Panasas has sponsored that code to make it into Linux, and now Linux has both initiators and targets for OSD. That architecture needed to be demonstrated. So, in fact, at CMU, we built a file system on top of the object storage, and we tried to give it away to the storage vendors and to the file system vendors, and it just was too vertically integrated to be taken, even though this is 1999, and because the bubble's happening and people are really excited, so couldn't give it away, and people were saying, why don't you start a company? So I did. So Panasas came out of the 1995 to 1999 research on storage architectures that could scale very well. So Panasas has the basic architecture of a intelligent device, the object storage device, and a very smart file system that gets out of the way but manages a large collection of them. We put this together in the early 2000, went into production in 2004 with most of our customers. And the other thing about this was that it embodied this scalable RAID that I was talking about. Panasas calls it Object RAID because we do RAID across servers. Almost everybody does RAID 0, that is, no protection at the level of the file system over multiple servers, and then they build highly reliable RAID, hardware RAID, into the individual servers. And we've always felt that that is not scalable enough. You can see stuff like us in the Google file system. They do replication in order to be able to scale the reliability out. You can see a little bit of this in Isilon. You'll see more and more people doing this type of an architecture in order that the file system can scale over ever larger amounts of storage. So Panasas built this in the early days, and when we started the Parallel NFS, which was we went to the IETF meeting in 2003 and said, hey guys, NFS needs an architecture that has good scalability in it. 2004, the IETF accepted it into the charter. 2008, they finished a proposal. 2009, the editor wrote it. And early 2010, we had an RFC for NFS version 4.1, which we call Parallel NFS, PNFS. And then we've been working on Linux introduction, and so 16 months after that, we started to get Linux releases. At this point, there are PNFS code in Linux, in kernel.org, for all three of the back-end protocols that we thought were interesting. And in fact, we just 2 weeks ago got RAID over servers put into Linux for this capability. So to go back to the original question, who am I? I'm an academic researcher for storage systems that has decided that to have an impact on the world, I have to do a lot more than just write papers. I have to leap in with both feet and produce solutions that solve customers' needs. And I've always been interested in scale and reliability, which has attracted me to the largest data sets and the fastest data sets in HPC and big data.